Okay, in this video, we're going to go over how to factor a difference of squares when there are multiple difference of squares pairs in the question. We have two examples here. This first one says x to the fourth minus 81. And I'm just going to go ahead and write over here on the side our formula for difference of squares. It is a squared minus b squared. We'll factor into a plus b times a minus b. So our goal is to get everything as a squared term. So what we're going to do is rewrite these two terms here as squared numbers. So instead of writing x to the fourth is the same thing as x squared times x squared, or x squared whole thing squared. So x squared whole thing squared, and then we could rewrite 81 as 9 squared. Now this looks more similar to a squared minus b squared. And I'm just going to go ahead and identify that this indicates that a squared is x squared squared, so a would be equal to just x squared because the square of it is a squared. B squared is equal to 9 squared, so b would be equal to 9. And now we're just going to write it in the format that we have over here, which is a plus b times a minus b. So a is x squared, so x squared plus b times a minus b, x squared minus 9. So here would be our first round of difference of squares. Now I'm just going to identify, could I factor either of these factors farther? This factor here, this binomial, could not be factored any farther as it's not a difference of squares or a sum of cubes because there's no cube terms here. But this second one right here, this could be factored farther because it is a difference of two squares. Our first number is already squared, so we're just going to rewrite that. X squared is already squared. And we could rewrite 9 as 3 squared. So now you'll notice this again looks like a squared minus b squared. I'm just going to go ahead and label. If a squared is x squared, then a is x. If b squared is 3 squared, then b is 3. And I could just rewrite this as a plus b times a minus b. So x plus 3 times x minus 3. And these could not be simplified any farther as there's nothing that you could take out greatest common factor wise, and neither of them are a difference of squares or difference or sum of cubes. I'm just going to bring down my original factor here, and this would be our answer, fully factored. Okay, if you want to go ahead and give the next one a try, you can pause. I am just going to start going over it though. This one here is a 3x to the fourth minus 48. Because this does not start with just an x to the fourth like our first one did, I knew this had a greatest common factor of 1 because our front term was 1. This one here, our front term is not 1. So I'm just going to double check. They don't have a greatest common factor that could be factored out of the entire thing before I start working with my difference of squares. So my smallest term is a 3. That means my greatest common factor could be any of the factors of 3, which are 1 and 3. So we can check if 3 would go into 48. 3 does go into 48. If you're not sure how to do that in your head, you can always use a calculator, or there's a trick to know if it will divide in. Anything is divisible by 3 if you add up the digits and they add to a multiple of 3. So 4 plus 8 would be 12. That's why we know 48 can be divided by 3. And that will go in 16 times. So our greatest common factor is 3. Put that out front. And I'm going to divide out or factor out my 3. And 3x to the fourth divided by 3 would just be x to the fourth minus 48 by 3 we already said was 16. Now, I know my greatest common factor, which is a single term, is already factored completely because there's nothing that could factor out of just a 3. Now I'm going to check my second factor here. This could be factored because this is a difference of squares again. I'm checking if both my terms could be written as squared terms. So instead of writing x to the fourth, I could write x squared squared. Instead of writing 16, I could write 4 squared. And now I'll do the same thing. This now looks like a squared minus b squared. So I'm just going to rewrite, first I'm going to write my a and my b. If a squared is x squared whole thing squared, then a is just x squared, the inside of these parentheses here. If b squared is 4 squared, then b is 4. Now I can go ahead and write a plus b times a minus b. And don't forget, we're bringing down our greatest common factor this whole time to our answer. Now from here, I asked myself, could I factor any of these any farther? This one cannot be factored farther as it is not a difference of squares or a sum of cubes, and there's no GCF that can be taken out, so it's just going to stay there like that. Our second one, though, this could be rewritten as a difference of squares. It already has a squared term in front. It has a difference right here, a subtraction sign, and 4 is a perfect square. It could be rewritten as 2 squared. So now this looks like a squared minus b squared. If a squared is x squared, then a is x. If b squared is 2 squared, then b is 2. So I could rewrite this as a plus b times a minus b. I'm going to bring down all my other factors that I already have written down. Don't forget your GCF, and this would be our answer, these 4. Hope this makes sense. Good luck.